Hello students, good evening. From today onwards, I am going to explain chemistry revision classes for NEET and JEE. So first of all, I want to start with organic chemistry. In the organic chemistry, first I want to explain qualitative analysis. In this qualitative analysis, we have to identify the elements which are present in the organic compounds. Basically, organic compounds will contain carbon and hydrogen. Along with carbon and hydrogen, some other elements like oxygen, nitrogen, sulfur, and halogens also present. Okay, how we can identify those elements? That detection or that identification of elements in the organic compounds is called qualitative analysis. So in this first we are going to detect carbon and hydrogen. Detection of carbon and hydrogen. Okay. So how we can detect the carbon and hydrogen in a given organic compound? So if an organic compound containing carbon are heating with CuO, this is also called as copper 2 oxide. Copper 2 oxide or cupric oxide. Okay, and heating with CuO gives a gas CO2 and Cu. If you balance this one, 2Cu and 2Cu. Okay. So this gas will come, that gas CO2 or some other gas we don't know. So if it is carbon, that gas is CO2. How we can confirm that is CO2? This CO2 by passing through lime solution. By passing through lime solution, CaOH twice. By passing through lime solution, we can get a white, milky white precipitate called CaCO3. Milky white precipitate called CaCO3 you will get along with H2O. So in this way, if milky white substance is found means that gas is CO2. That gas is CO2 means in the organic compound carbon is present. In this way we can identify the carbon. Next, hydrogen. How we can identify hydrogen? So organic compound containing hydrogen on heating with CuO. Again same only. Organic compound containing hydrogen and heating with CuO. Here it will give one liquid H2O and Cu. One liquid H2O and Cu. Okay, this liquid is H2O or some other liquid of how we can identify. If it is H2O, in the organic compound hydrogen is present. So if that liquid is passed through anhydrated CuSO4, anhydrated CuSO4. Anhydrated means it is also colorless. Then it will give a blue color solution. CuSO4 5H2O. It will give a blue color solution. This blue color solution formed means that solution is, that liquid is water. That liquid is water means in the organic compound what is present? Hydrogen is present. In this way we can identify the carbon and hydrogen in a given organic compound. Okay. Next, this is the first one. Next we are going to discuss remaining elements. Remaining elements how we can identify. So remaining elements are identified by the Lassaigne test. Lassaigne test. In this test, we can identify the elements like nitrogen, next sulfur, next halogens. Halogens means MCl, Br, I, and phosphorus. These elements can be detected by the or identified by the Lassaigne test. So in this Lassaigne test, we have to prepare sodium fusion extract. Sodium fusion extract. Simply SFE. Okay. So what is SFE? Sodium fusion extract. How we can prepare this one? Organic compound plus sodium metal plus water, heat This you have to heat this mixture, later filter. Okay, so organic compound, sodium metal, water is added, later heating. After heating for some time, if you filter, okay, if you filter, the filtrate is called sodium fusion extract will get. The filtrate is called sodium fusion extract that will get. So during this sodium fusion extract formation, covalent bonds covalent bonds are converting into ionic bonds. Okay, during the preparation of sodium fusion extract, the covalent bonds, the organic compounds are converting into ionic bond. If you take one example, for suppose in the organic compound nitrogen present, then that contains a sodium fusion extract NaCl. The organic compound sulfur present, then that are heating with sodium metal, sodium fusion extract contain Na2S. These are SFEs, sodium fusion extracts. Similarly, if halogens present, Na plus X will give NaX. If Cl, NaCl, Br, NaBr, iodine, NaI. These are the sodium fusion extract. If nitrogen present, this is the sodium fusion extract. If sulfur present, this is the sodium fusion extract. If halogens present, NaX is the sodium fusion extract. In this way, after forming the sodium fusion extract, we can identify the corresponding element by doing corresponding methods. Okay, so this is about a Lassaigne test. Now, after Lassaigne test, first we are going to identify nitrogen. How we can identify nitrogen in the given organic compound? Okay, so detection of nitrogen. How we can identify nitrogen in a given organic compound? So, if nitrogen is present, means what is a sodium fusion extract? To the sodium fusion extract, if we add acidified FeSO4, then what will get if a Prussian blue color came, then nitrogen is confirmed. Okay, so here in this detection of nitrogen, what is the sodium fusion extract contains? NaCN. NaCN on reaction with the FeSO4. What it will give? FeCN twice. Okay, FeCN twice it will give plus Na2SO4. Na2SO4 if you take 2 moles. This FeCN twice again on reaction with 4 moles of NaCN. Then what will get? Na4 FeCN6, and complex compound will get sodium hexacyanoferrate. Will get. Okay, so this sodium hexacyanoferrate on heating with Fe plus 3. How this Fe plus 3 came? This acidified FeSO4. Okay, acidified FeSO4 means in the presence of acid. Okay, FeSO4 in the presence of acid. That acid will convert Fe plus 2 into Fe plus 3. Here we can take FeCl3 or Fe2SO4 thrice, those compounds also you can take. Mainly here the oxidation state of iron will be plus 3. So if it is combined with this one, okay, if it is combined with this one, then what will come? Fe4, FeCN 6 times. Okay, so here this one is a Prussian blue color. Okay, here this one is Prussian blue color. So this compound came means in the organic compound nitrogen present. So simply to the sodium fusion extract, if you add FeSO4 Prussian blue color came means nitrogen is present. What is the composition of the Prussian blue color means? This is the answer. We will ask sometimes composition. So Fe4 FeCN6. Okay. Right. Next, by using this test, in all the compounds we can identify except to diazo compounds. Okay, except to diazo compounds or diazonim salts. Okay, so it fails in diazo compounds. Diazo compounds. Why? Diazo means N triple bond N. So this compound containing this diazo structure containing compounds are heating, immediately this will be removed as N2. Immediately this will be removed as N2. So in this case we will not get NaCN. We are not getting NaCN means we cannot get this color. So that's why detection of nitrogen fails in case of which compounds? Diazo compounds, very very important. Okay. So this is about nitrogen. Next is sulfur. How we can detect the sulfur when given organic compound? Okay. So detection of sulfur. Detection of sulfur. In this case, to the SFE, we have to add lead acetate. Then, if black color precipitate came, then sulfur is present. So here, sulfur is present means what is the sodium extract Na2S. So to this, if you add lead acetate, CH3COO, Y is PB, then this S will go and act to the PB. Then what will get? The PBS will get. PBS. This is only black colored substance. And what remains in this reaction? Acetate ion and Na. So what will get? Sodium acetate. 2 moles of sodium acetate will get. So mainly the composition of black color means PBS. So PBS we are getting means in the given organic compound sulfur is confirmed. Okay. So for this one more method is there. For the sulfur to the SFE, if you add sodium nitroprusside. Okay, if you get a violet or purple color, okay, violet or purple color, in this case also sulfur is present. Okay, so here sodium nitrate formula Na2S. If sulfur is present, then sodium nitroprusside means Na2 FeCN 5 times NO. This is the sodium nitroprusside formula. So to this SFE is added means the 2Na will add here. Next this S will add to the NO. Then Na2, this Na2 also added, then it will become Na4 FeCN 5 times to the NO. What is added here? This S is added to the NO. S. Then it will become NOS. So this is a sodium thionitro. Okay, S is added now, so thionitroprusside, sodium thionitroprusside. This is which color compound? Purple or violet color compound. This compound formed means the given organic compound what is confirmed? Sulfur is present. Sulfur is confirmed. Okay, detection of N and S. Okay, so in this, if both elements nitrogen and sulfur both are present in the given organic compound, how we can identify? So here, yes, to the SFE you have to add FeCl3. Then if you get blood red color, then in the given organic compound both nitrogen and sulfur are present. Here SFE, what is SFE? If sulfur and nitrogen present means NaSCN. To this FeCl3 is added, then what will get? Fe. Here what we get? FeSCl 3 times we get. This is one formula. Sometimes they will give FeSCl, they will form a complex plus 2. Okay, so this one both are same only. If this is forming a complex means it can form like this, or else this one. So this is which color compound? Blood red color. So blood red color composition means FeSCl twice they can give, or FeSCl plus 2. Okay, this also they can give. This is the, in this way we can detect the nitrogen and the sulfur. the given organic compound. Detection of halogens. Detection of halogens. The given organic compound, how we can detect the halogens, or how we can identify the halogen. Here, before going to test halogens, first the SFE, you have to react with the dilute HNO3. Before going to test halogens, first we have to add dilute HNO3 to the SFE. Why we have to add? If suppose if nitrogen is present, means what is the sodium phase extract NaCl. So this is added to this NaCl, HNO3 is added, means the nitrogen will be removed in the form of HCl and NaNO3 will get. Okay. Similarly, if sulfur is present, then what is the sodium phase extract Na2S? To this, if you add HNO3, okay, to this if you add HNO3, here also it will be removed as NaNO3 and H2S will get. Before going to test halogens, we have to add dilute HNO3. Why you have to add dilute HNO3? In the sodium phase extract, if nitrogen component is present, okay, NaCl will be formed, that will interfere the reactions of halogens. If sulfur is present, okay, what is the sodium phase extract Na2S also will be present, that will interfere the reactions of halogens. So that's why, okay, first you have to add HNO3, then the nitrogen impurity means NaCl or sulfur impurity means Na2S. These two will be decomposed in the form of HCl and H2S. So after removal of these two, okay, nitrogen impurity and sulfur impurity, then we can test for the halogens. Okay, then we can test for the halogens. So in case of halogens, to the SFE you have to add AgNO3. To the SFE you have to add AgNO3. So suppose chlorine is present, NaCl, then this are reacts with AgNO3. What will get? AgCl will get, which is a white color precipitate. White color precipitate and NaNO3 will get commonly. Okay, this is soluble in NH4OH. Okay, next if suppose if bromine is present, then what is the sodium phase extract NaBr? So this are reaction with AgNO3. Here what will get? AgBr will get, which is a pale yellow PPT. Okay, pale yellow PPT. This is partially soluble in which one? In NH4OH. Partially soluble in NH4OH. Okay. Similarly, iodine. If iodine is present, then what is the sodium phase extract NaI? To this, if you add AgNO3, what will come here? AgI will come. And what is the color? Yellow. It is insoluble in NH4OH. Okay, so in this way, we can identify the halogens in a given organic compound. And for halogens, one more test is there, Milstein test. Okay, so in this test, we have to take a copper wire. Okay, so we have to take a copper wire. One end you have to flatten. Later, this you have to put in the flame. Okay, this you have to put in the flame. Then it will give. Initially, it will give blue. Okay, so we have to heat until it gives white flame. Okay, you have to take a copper wire, you have to flatten one side. Okay, initially it will give blue color until white color came. You have to heat. Later this end you have to dip in the organic compound. Okay, this end you have to dip in the organic compound. If you heat again, okay, if it gives blue color, okay, by heating again, if it gives blue color, then the halogens are present in the given organic compound. Explaining once again. So in the Milstein test, you will take a copper wire. Okay, one end you have to flatten, you have to heat. Initially it will give blue color. Okay, you have to heat till it gives white flame. Okay, later this part you have to dip in the organic compound. Again you have to heat. Okay, by heating, if you get blue color, then in the given organic compound, halogen is present. Okay, and it will not specify. Okay, it will not specify which halogen is present. It will not specify which halogen is present. And okay, for this one, small exception also is there. Okay, this test is positive for urea, and thiourea. Okay, so along with halogens, in these two cases also, same test will get. So this is one exception. Except for urea and thiourea, in the remaining cases we can use the drawback. This test is given by urea and thiourea also. Detection of halogen is completed. Next one, detection of phosphorus. Detection of phosphorus. So how we can detect the phosphorus in a given organic compound? Okay. So phosphorus present in the organic compound. Phosphorus present in the given organic compound are heating with the sodium peroxide. What will we get? First we get phosphate, sodium phosphate. Okay. Plus so sodium phosphate we get. So this sodium phosphate Na3PO4 on heating with the H3PO4. Sorry. And heating with this sodium phosphate on heating with the dilute HNO3. It will give H3PO4. Phosphoric acid it will give. Okay, phosphoric acid it will give. To this phosphoric acid, okay, you have to add ammonium molybdate. NH4 twice. This is ammonium molybdate. To this ammonium molybdate, sorry, to the phosphoric acid, ammonium molybdate is added along with HNO3. What will you get? Ammonium phosphomolybdate, you will get NH4 thrice PO4 MOO3. So phosphomolybdate will get along with H2O. So this is which color? Canary yellow color precipitate. Okay, this is the canary yellow color precipitate. This canary yellow color precipitate confirms the presence of phosphorus in the. This canary yellow color compound confirms the presence of phosphorus in the given organic compound. This is the detection of phosphorus. Organic compound containing phosphorus on heating with sodium peroxide gives sodium phosphate. This sodium phosphate on heating with HNO3 gives phosphoric acid. Phosphoric acid on heating with ammonium molybdate, and HNO3. What color it will give? Canary yellow color compound it will give. What is the composition of the canary yellow color compound? Means NH4 thrice PO4 12 MOO3. Okay, so this is the canary yellow color compound. Okay, right. Next, last one, detection of test for oxygen. How we can identify? There is no direct test for oxygen. Okay, so there is no direct test for oxygen, but we can identify the given organic compound oxygen is present or not. How we can identify it? You have to take a dry test tube. In the dry test tube, if you add organic compound and if you heat for some time, after some time on the walls of the test tube, small droplets, okay, small H2O droplet, water droplets, okay, water droplets found means then in the given organic compound oxygen is present. It may be alcohol, it may be CHO, it may be COH, okay, because in all these oxygen atom is present. Okay, so that's why there is no direct test for oxygen. We have to identify the given organic compound oxygen is present or not by heating in a dry test tube. Okay, if water droplets are formed on the walls of the test tube, then oxygen is present. It may be any functional group, alcohol, maybe okay, aldehyde or carboxylic acid. Right, this is the qualitative analysis. Okay. Carbon is estimated in the form of CaCO3. What is the color? Milky white. Okay, next hydrogen is estimated in the form of CuSO4 5H2O. What is the color? Blue. Similarly, nitrogen is estimated in the form of which one? Fe4 FeCN6. Okay. So what is the color? Prussian blue. Prussian blue. Next, how sulfur is estimated? Sulfur in two ways. Okay, sulfur in two ways. One is PBS. PBS, what is the color? Black. Another one, sodium thiohydroproside. So Na4 FeCN6 times NOS. Okay, so what is the color of this one? Violet or purple. Next, if both N and S both are present, then what is the color? What is the composition of FeSCN plus 2, like this you can write, or FeSCN, right? So this also you can write. What is the color? Red color. Next, if halogen is present, halogen, if suppose Cl present means AgCl. What is the color? White. Okay, if Br is present, then AgBr. What is the color? Pale yellow. If iodine present, then what is the color? AgI. Okay, what is the color? Yellow. Okay, if phosphorus present, then what is the composition of NH4 thrice? Okay, PO4 12MOO3. Ammonium phosphomorphate. What is the color? Canary yellow color. Okay, so in this way, by knowing these compounds composition, so we can identify the element which element is present in the given organic compound. Next, in case of nitrogen, few questions they will ask. They are very important. Nitrogen can be detected in which of following? In which of the following nitrogen can be detected? Okay, nitrogen can be detected in which of following? Okay, first option, first of all CH3. Okay, NH2. Okay, second option, nitrogen given. Third option, okay, third option, NH2 NHCl. NHCl, for suppose. Okay, one hydrogen here in the hydrogen, one hydrogen is replaced by HCl. And last one, this is hydrogen hydrochloric acid, and one more NH2 NH2. Or sometimes it is also called as N2H4. Okay, so in this case, here nitrogen, how we can identify? By forming the sodium phase reactant NaCl. So to form the NaCl, along with the nitrogen, that organic compound should contain carbon also. Okay, here carbon is there, nitrogen is there, so it can be detected in this. Here also carbon is there, nitrogen is there. In this case, no carbon. So in this case, nitrogen cannot be detected. Next, here also no carbon, so in this case also nitrogen cannot be detected. So in these two cases, that test is failing. Okay, so in this way, we can easily solve the questions based on the qualitative analysis.